November 14, 1854. Crimean Peninsula. A strong gale suddenly sweeps through the bay near Balaklava and sinks dozens of warships and supply ships of the British and French armies. Hundreds of soldiers die, not in battle, but because of the weather. This tragedy shakes the world. French Emperor Napoleon III asks scientists, could this not have been predicted? And so modern meteorology begins. Not as an academic discipline, but as a tool to save lives. Today, we look at the fascinating story of meteorology from its origins to the present day, the only science capable of predicting the future. It is the year 2025, and meteorology stands at the technological peak of its history. More than 30 active meteorological satellites orbit Earth today, continuously monitoring the atmosphere, oceans, and land surface. The most significant include the Meteosat third generation, MTG, satellites over Europe, GOES-R over America, and Himawari 9 over Asia. Today's meteorologists observe atmospheric events almost in real time. Modern satellites capture images of Earth every 2 to 10 minutes, and the best quality images can resolve details as small as a few hundred meters. Thanks to this, we can now observe the formation and development of storms or cloud cover with a precision unimaginable a few decades ago. Weather forecasts today are calculated on supercomputers capable of processing billions of equations within seconds. The global ECMWF model, considered one of the most accurate worldwide, in 2025 has a horizontal resolution of about 9 kilometers, forecasting atmospheric development on more than 130 vertical levels. The German ICON model, in its regional configurations, has a resolution approaching 2 kilometers. Slovakia is no exception with the Numerical Aladdin model, a product of international cooperation among Central and Eastern European countries, achieving a resolution of 2 to 4 kilometers. This allows for weather forecasts even in the complex terrain of the Carpathians with fairly high accuracy. Today's weather forecasts are not just about whether it will rain tomorrow. They are used in aviation, energy, civil protection, and agriculture. They help save lives and reduce damage during extreme events like floods, windstorms, or heat waves. Now imagine if we had none of this. Imagine a world without weather forecasts, no mobile apps, no storm warnings, no radars, no satellite images. People lived in such a world for thousands of years. Their only tools were the sky above, nature observations, and knowledge passed down from generation to generation. The history of meteorology is a fascinating journey from ancient beliefs to modern science. Let's take a closer look at this journey. The first attempts to explain and predict weather come from ancient Mesopotamia, Egypt, and China, where records of rain and drought were kept for agricultural needs. In ancient Greece, the famous Tower of the Winds was built in Athens in the 1st century BCE, a structure showing wind directions with an octagonal orientation. The most famous work from that period remains Aristotle's Meteorologica, written around 340 BCE. It was the first book to systematically attempt to explain why rain, wind, thunder, lightning, or rainbows occur. Though full of errors, such as the idea that wind was caused by vapor escaping from the earth, it influenced weather understanding for the next 2,000 years. During the Middle Ages, meteorology became intertwined with astrology. Weather was often linked to the movements of stars and planets. People observed the moon phases, star clusters, and their connections to droughts, rains, or winters. Astrological calendars like Christoph Hellwig's Curious Calendar promised weather predictions for years ahead. It was not a scientific approach, but at the time, there was simply no better way to prepare for capricious weather. Change came with the Renaissance, and especially in the 17th century. Leon Battista Alberti, living in the 15th century, is often mentioned as the inventor of the first anemometer, a rotating blade device. The first practical anemometer was built by Robert Hooke around 1667. Galileo Galilei created the first thermometer based on liquid thermal expansion. His student Torricelli invented the mercury barometer in 1643, demonstrating that air has weight. Pascal followed, and in 1648 asked his brother-in-law to carry a barometer up one of the French mountains. experimentally proving that air pressure decreases with altitude. In 1660, Boyle introduced the concept of air compressibility. These and many other discoveries laid the foundations for quantitative meteorology. No longer was it enough to just watch the sky. Scientists began to measure. In 1722, Russian Tsar Peter I ordered careful weather records to be kept at key locations across his empire. In 1783, the first hydrogen balloon with a human crew took flight. On board, besides people, were a barometer and thermometer. The balloon flew for 2 hours and 5 minutes, covering a distance of 36 kilometers. This feat was witnessed by 400,000 spectators. In 1784, the concept of temperature decreasing with altitude was introduced, and 20 years later, the first meteorological balloon was built. It rose to an altitude of 6.5 kilometers, again with a human crew. At the same time, thermodynamics and atmospheric electricity research progressed. Benjamin Franklin discovered that storms move and are not static, a revolutionary idea for its time. In 1801, Lamarck created the first cloud classification, and less than 20 years later, the first meteorological map was created. It showed that wind direction and weather depend on air pressure, and that air flows toward the center of low-pressure areas. Francis Galton later introduced terms such as cyclone and isobar, and British Admiral Robert Fitzroy created the first daily weather forecasts printed in newspapers. In 1828, German physicist and meteorologist Heinrich Wilhelm Dove discovered that tropical cyclones rotate clockwise in the southern hemisphere, opposite to the northern hemisphere. He also found that weather results from the interaction of air masses with different properties. In the 18th and 19th centuries, meteorological networks were established across Europe. Regular temperature, pressure, and precipitation measurements were taken in capitals and rural areas alike. In 1781, the Societas Meteorologica Palatina was founded, uniting observations from dozens of stations in Europe and America. The real leap was made possible by the invention of the telegraph in 1840. Thanks to it, meteorological stations across the country could send data in real time to central locations, where synoptic maps were created, the first tool to understand atmospheric conditions over large areas. These maps helped meteorologists understand relationships between pressure systems, wind, and precipitation. In 1853, the first International Meteorological Conference was held in Brussels, convened at the initiative of American naval officer Matthew F. Maury. Its goal was to coordinate the collection and exchange of meteorological data from ships at sea. On the night of October 25th to 26th, 1859, the steamship Royal Charter sank off the coast of North Wales during a severe storm. Robert Fitzroy investigated the causes of this event and began creating the first synoptic weather maps. These maps showed pressure fields and wind conditions, helping better understand and forecast storms. In 1860, Fitzroy published the investigation's conclusions in newspapers, which included these main points. During the 19th century, organized weather measurements also began in what is today Slovakia. Among the most important was the observatory in Hrbanovo, one of the oldest meteorological stations in Central Europe. It was founded by Mikuláš Konkoly-Thej in 1871. The observatory also organized the first storm observations involving over 500 volunteers across Slovakia. Systematic measurements began here in the mid-19th century, and the observatory later joined international meteorological networks. Around this time, the first state meteorological institutions were created within Hungary, responsible for regular data collection and processing. At the turn of the 19th and 20th centuries came the era of physics. In 1889, Wilhelm von Basalt distinguished between adiabatic and pseudoadiabatic air ascent in the atmosphere. In adiabatic ascent, no heat exchange occurs with the environment, and the air parcel cools only due to expansion. In pseudoadiabatic ascent, condensing water vapor releases latent heat, slowing the cooling of the air and influencing cloud and storm development. The Norwegian school of meteorology emerged, introducing key concepts like warm front, cold front, and frontal cyclogenesis. These concepts still form the basis of most weather forecasts today. In 1922, Lewis Fry Richardson made the first attempt at numerical weather prediction using mathematical equations of atmospheric dynamics. However, the calculation was very demanding and unsuccessful because he lacked sufficient computational resources and accurate input data. Nevertheless, his work laid the foundations for modern numerical weather modeling. Just 2 years earlier, the State Meteorological Institute was established in Prague, Czechoslovakia, which later merged in 1950 into a joint meteorological institute. Starting in 1933, upper-air synoptic maps began to be drawn, and 4 years later, aerological measurements using meteorological balloons were regularly conducted. After World War II, numerical weather prediction began to take off. In 1950, scientists from Princeton University and the U.S. Army computed the first 24-hour forecast using the ENIAC computer. It took several hours, but it marked the beginning of a new era. In the 1960s, radars started to be used as well, capturing precipitation echoes in the atmosphere and enabling near real-time monitoring of storm development. In 1960, the first meteorological satellite TIROS 1 was launched, opening the way for global cloud observation. Over the following decades, satellites became key tools in meteorology. Around 2000, systems like EUMETSAT in Europe, NOAA in the USA, and JMA, Japan Meteorological Agency, in Asia began operations, alongside the rise of commercial satellites. In 1975, the European Centre for Medium-Range Weather Forecasts, ECMWF, was established to pool expert knowledge and computational power to provide more accurate weather forecasts for periods up to 10 days. The Slovak Hydrometeorological Institute was founded on January 1, 1969, by the Ministry of Forestry and Water Management, and since March 1993, the independent Slovak Republic has been a member of the World Meteorological Organization. In the early 1990s, an international consortium led by Meteo France was formed to develop a regional weather model derived from the global ARPAGE model. The result of this cooperation was the Aladdin model, which entered operational use in 1994. Today, in 2025, satellites track even the smallest details. They can monitor hurricanes over the oceans, detect fires in the Amazon, and track dust storms over the Sahara. Meteorology has become a global science, interconnected, precise, fast, and increasingly accessible. But it still has its limits. As Edward Lorenz showed in the 1960s, the atmosphere is a chaotic system. Small measurement errors lead to completely different forecasts, thus, chaos theory was born. This means that while we can predict weather well a few days ahead, forecasts for longer periods vary significantly. And that is why meteorology will remain so fascinating despite all advances. It still requires a blend of art, patience, and humility before nature.